Hello, my name is Chmarny. I work as a data solution evangelist at VMware. Today I want to show you a short demo of a sample application I put together to go along with a blog post on increasing performance and scalability of web applications using SQLFire. The entire post, along with source code link, is available on a vFabric blog. In this demo, we use Spring Framework to configure two instances of the same web application with two different data sources, one pointing to MySQL, the other one pointing to SQLFire. Additionally, to resemble real web server stress over underlying databases, the demo exposes REST API, which we'll use to saturate both of these apps with a large number of requests. To mimic real-life scenario, the demo is deployed in a shared hosting environment in a two-tier architecture. Web server and database are hosted from separate VMs. On the data side, we have pretty simple database. We have requests. Each one of the requests has number of orders. Each one of the orders has number of items. The demo app will perform numerous inserts, updates, and deletes into each one of those tables. So let's start our test. We'll configure it with 500 requests, 10 orders, and 5 items. Let's start with MySQL test first. Obviously, there's many variables that can impact database performance, and since we are running this demo in a shared environment, the performance will greatly vary. To minimize the impact of these variables, the demo only compares the actual time that it takes to commit each one of those transactions to the database. The calculated duration time does not include request generation, network latency, or REST deserialization. I'll pause the video to spare you the excitement of watching a progress bar go by. But as you can see, MySQL took on average 107 milliseconds to commit each one of those transactions to the database. To compare, let's run the SQLFire test now. Same values, same servers, same application, just different database. Now SQLFire is a memory optimized database. It's been built for speed and low latency. So to make things a little more interesting, I configure SQLFire in addition to processing SQL commands to also replicate asynchronously each one of its requests to the other database. As you can see, SQLFire is substantially faster, about 50%. In a sense, we have drastically improved performance of the web application while continuing to support legacy database. And we can do that at scale, as if you need more power, just add more servers, as well as higher availability due to SQLFire distributed nature. Hopefully, you've got a glimpse of the type of performance improvement that SQLFire can deliver in your application. You can download the source code of this demo from GitHub. Additionally, since SQLFire license allows for up to 3 free nodes in development environment, go ahead and see what type of performance gains SQLFire can deliver in your application. Thank you.